Morning, guys. Welcome back to another video slash reading session. Last week's material is pretty much the same concept for this week. I'll be providing you guys reading material that's more theory, and as expected, since we did hardware last week, we're gonna be doing software this week. I hope you guys had covered this already in first form, but if you guys don't remember, today is gonna be a little refresher course for you guys. So we talked about hardware last week, and we know that the hardware are all the physical components of a computer system. Talking about keyboards, monitors, CPU, speakers, webcams, mouse, and so forth. All items, all things, objects that are physical in nature. However, one thing I didn't say last week was that anything that's not the CPU of a computer system is called the peripheral device. Alright, so please note that word peripheral are all parts of the computer that are not the CPU. Should be easy enough to remember, right? So this week we're gonna focus on software, and software is the opposite of hardware. Are all the things that are non-physical. You cannot touch them. They're not really objects in this time, space / reality. So that's why we call it software. It's not tangible, but it is just as essential, if not even more essential, than the hardware. Software is developed using code nowadays. We use programming languages, and they are developed by programmers or software developers, and they have to write out the code to instruct the software, to instruct the hardware on what they need to do. When we're writing in code as programmers, we're writing in a way so that the hardware can communicate with the software. Back in the earlier days, when we had binary allows the computer devices to communicate with each other, right? But we can't read binary quickly. I'm sure there's someone out there who can read it much faster than everyone in the entire world, but I'm sure he or her cannot read binary as fast as a computer device. So nowadays we program with different languages that resemble English, but those languages are further converted into binary as they are run by the computer. So what I'm saying essentially is the software tells the device what and how to run. That's what makes it so important. Without these instructions, we wouldn't be able to control the hardware. If you look at a computer and you didn't know what all can be done with it, I don't know if you've seen movies where they depict kind of like cavemen or old historical people interacting with a computer. But there are some movies like that where people have traveled to the past, shows a computer to someone from the past, and they basically think it's witchcraft. But like I said, back to the main point, if you didn't know what a computer did, you just see it as one pile of scrap metal or plastic, and if you'd open it up and show someone, they'll be like, okay, well, they'll probably try and bash it against a rock or try and use it to kill an animal or something. But software enables us to control a computer meaningfully, so we're able to run other software like Microsoft Word, YouTube, and so forth. So it is really the software that allows us to make use of the hardware efficiently and meaningfully. And we didn't always have software. Back in the older days, in the 1950s, computers were controlled using punch cards. So it wasn't using software, but it was using something physical as well. On right here, you can see a picture of a punch card. Why it's called punch card? Because there are holes punched into it at specific areas, and these specific areas are read by a huge machine on the left picture. And basically, depending which punch cards are pressed, the machine or the computer will know what it needs to do, right? Or needs to know what needs to be calculated, right? I haven't used one of these. I wasn't born in the 1950s either, so don't quote me on how exactly it's used. But imagine you'd have to punch out a card carefully every time you wanted just one single thing to be done. Imagine you want to open a video, alright, you have to punch 1, 5, this one here, that one there, and then you have to run that into the computer to watch a video. You want to watch a different video, well, guess what? You have to punch a next set of cards. You want to watch another video, repeat. You want to type in something, punch the card. You want to copy this file, imagine punch a card. Imagine for every little minute thing you had to do with the computer, imagine you'd have to punch a card to run that instruction. Now you see why it's not efficient, right? But today we have software, and we have two different types of software. There are two different categories that allows us to accomplish a lot of different things with computers nowadays. We have the operating software, or the OS, and then we have the application software, or we just call them apps nowadays, right? These two categories are their own because each one does something specific, and one has a lot more priority and power than the next one. You always hear about an OS when it comes to computer, right? But what is the OS? The OS is software that manages everything on a computer. When it comes to all the hardware devices, the OS is what allows you to communicate with the hardware. You don't just come to a keyboard and say, alright keyboard, type out the word operating system. The keyboard doesn't type it, right? You have to physically type on the keyboard, and even then, it's not like you're the one that's controlling the electrical signals that goes from the keyboard to the CPU or to the motherboard. It's not like you can put your hand on a computer and just start transferring electrical energy from yourself into the computer, and then from the keyboard into the CPU, and it starts typing, right? That's kind of superhero stuff. And I'm pretty sure even if a superhero had electrical powers, they still wouldn't even be able to control hardware to that effect, because then you can't just send a stream of electricity and say, alright, well, this is what's going to happen, right? It has to be specific, it has to be controlled in a way. That's what the operating system does. It controls those communication between hardware. So all these devices that we talked about last week is controlled by the operating system. Some major examples are like when you're trying to transfer information, like when you're copying a file and pasting it from a USB onto the hard drive and so forth. The OS handles that because the OS needs to go and check, well, does the hard drive even have enough space to take in this file you're trying to copy? So it has to do all of that first, because then if you're trying to copy a file that's really large and it can't fit into the hard drive, and if the operating system doesn't check that and stops it, then you might run into an issue where you run out of memory. And if you run out of memory, it can cause glitches or it can cause errors that pop up. So operating system makes sure everything is safe and everything is proper before something is done, or at least it tries, because it's not like we don't see operating system crashes nowadays, right? That blue screen of death, right? So it's not perfect, but it's the responsibility, and if it fails, then you get blue screens of deaths, or computers freezing up. So the computer also monitors the status of the computer. So we're talking about memory management, kind of what I just talked about just now. And then it also controls the communication between devices, which again I mentioned earlier. So everything pretty much goes through the operating system. All hardware devices will also note all apps as well. So the operating system is kind of like the boss of the computer, and everything needs to get an okay from the boss before it happens, right? all applications that are created by software developers as well need to how to say be confined or be constrained by the rules of the operating system. So that's why when you have developers and they say they're going to develop something for Android, they have to adhere to the rules of Android. And the same thing for iOS. If they're going to create an app for an iOS device, then they have to adhere to the rules of the iOS device's operating system. And I won't get into it too much, but that's why some programmers might have issues like when they're releasing an app and there are some glitches on one device but there aren't in the other. It's because of the operating system being different, right? We can't handle every possible scenario, but they try, right? So that's the point I was trying to make. Everything goes through the operating system. There are cases where it doesn't, but it's something you need to know what you're doing. You're setting up a BIOS or something like that, but I won't get into that too much, alright? So that's pretty much what the OS is, and now we move on to the application. An application is still software, but it's software that was created to do a specific task. All software, all application software out there has one main task that it was created for, but you might want to argue that software nowadays are very robust, meaning they can handle a lot of different things. For example, Microsoft Word was created to type, right? It was created to write out reports, print them, and use them to convey information. But nowadays, you could paste in pictures, you could paste in diagrams, tables, and so forth, which are not really words, right? Even though it's in the name. But all of these things are integrated to help boost or to help basically to help you convey information even better. It's still related to the words that you type. For example, with the picture up here, yes, it's a picture, but it still relates to what I'm talking about in the descriptions above. So those are what we call features, right? Any additional functions that may not seem like it pertains to what that specific task is called a feature, right? So Word, you're supposed to use it to type, but it's not limited to typing. You can include pictures to help convey your point, and that's a feature, right? You have Notepad. You can't paste pictures in Notepad, right? That's not a feature of Notepad. Notepad is just basic. You write out what you need to write out, right? Notepad doesn't even have stuff like changing colors, I think, or I've never used it in Notepad. I'm not sure if you could even put numbering in Notepad using the numbering key or button in Microsoft Word. You'd have to do that yourself by tabbing out. So all of these are features from the most minute or smallest to the largest, most robust, most in probably the coolest feature you could think of. So all of these are still just features that help the application do what it was designed to do. Alright, so even YouTube, if you look at this diagram here, even YouTube was made to just play videos, right, or upload videos. But all of you could just say is that YouTube mainly focuses on videos, right? But you could now upload your videos, you could now stream your videos live, and again, all of these are features because the main task of YouTube is videos. In just one word, what is the main task that YouTube deals with? Videos. All other features are to help relate to videos. Comments, well, comments usually relate to the videos. Likes on the videos, again, still relates to the videos because you're rating what? The video. Subscriptions, same thing. What does it do? It notifies you of when another video is posted up, and so forth and so forth. So on the right hand side of this picture, we have operating systems, some of the most common ones. You have Android, iOS, which are mobile operating systems, meaning they're for usually use on mobile devices, tablets, phones, navigation systems, so forth. Then you have Microsoft, you have Windows, right? We have Windows 10, which I'm using right now, and then the whole bunch of Windows that came before. Then you have Mac, right? And again, so much iterations of Mac beforehand. You also have Linux, Unix, all of those pretty much. But Linux is really popular among developers, but not really among just basic users nowadays, right? On the left hand side, you see all these applications: email, like the Gmail application, Google Drive, Outlook, some PDF application, browsers, so forth and so forth. All of these have one main task that allows us to do all kinds of things on a computer. You could really associate application types with like game genres, because let's say you want to play a shooting game, then there's like application for that, right? We just call it a game. We call it a first person shooter, a third person shooter, but it's still an application, right? If you want an application for racing, that's what we call a racing game. You want an application for an RPG, well, that's what we call RPG games. So applications are like different genres of software that does one specific thing with additional features, right? Alright, so just to wrap up, just to show you the levels of where the hardware, operating system, and application and you, the user, fall. We have hardware at the lowest level, meaning it's that you just have a computer, right? That you just have it. You're not doing anything with it yet. Then when you install an operating system, usually most computers, when you buy them, or laptops I should say, it comes with an operating system. That is one step above hardware, because that allows hardware to communicate with each other. Notice the arrows. The hardware must communicate with the operating system. Then the operating system, with down arrow, tells the hardware, alright, I need you to do this, I need you to do that. But when the hardware is communicating with the operating system, and you run an application again like Word, the OS tells the application, alright, I'll let you run. Alright, what do you need? Application goes and tells the operating system, okay, I want to type out this word. And then operating system tells the hardware, alright, well, keyboard, you're typing this word, right? Yep. Application, yep, he typed out the word. Alright, display the word on the application. Alright. So you see, it's a lot of back and forth, but we barely notice the time in between, because, you know, this communication happens in milliseconds, right? Quickly. And then what happens with the application is, well, it's the user that interacts with the application. Just like now, you're watching a video, we're using an application. The video is being run on the OS. Maybe you're on a mobile device. So if you're on Android, the video is playing on Android. If you're on iOS, video is playing on iOS. What's the hardware that the iOS is running on? It's on an iPhone 7, 8, 9, 10, 11. If you have the 11, yo, congratulations. If you have the latest hardware, cool, right? But you see this hierarchy of communication here. It really is a good model of what's happening with our devices at any given time. Alright, I'll stop here. As usual, Thursday we're gonna have an assignment. It's already created, I just need to post it, but I'll post it on Thursday. Give you time to read the notes. It's gonna be 10 questions just like last week, all pertaining to these notes here. Make sure you read it. It's not a lot. Try to keep it under 2 pages. And this is pretty much under 2 pages if you minus the images, right? So see you guys Thursday. If you have any questions before then, just send a comment, send an email. Please make sure you do your assignments. I'm using those to help boost your grades. You know who you are if you know you need it. If you're missing work that you need, you know who you are. Just make sure you get those assignments done, especially those from day 7 and up. Those are the ones after the Easter break. That's when I started to make your assignments be just the form, so you don't have to upload anything. Easier for you. So make sure you get those done before next month. Pretty much we're exactly 1 month before the last day of class, or the last day of the school year, which is going to end on the 19th of June. I sent that message in the classroom already, so make sure you get those done. Let's see, June 24th. Alright, sorry, it's June 9th. Yeah, June 19th. And your grades will be ready by June 24th. So I'll end there, guys. Have a good day.